So this video is about titration questions that are linked to redox, and this happens quite often at higher. So we're going to go over how do we tackle a titration calculation, specifically at how do we make sure we set ourselves up for success by reading the question correctly. When it comes to titrations at higher, it's just like National 5. There are 3 marks available, but you have to do a lot of preparation before you get any marks. So the first thing you need to do, read the question carefully to identify which are the 2 chemicals you care about and what values do you know about them. So you should know the concentration and volume of one chemical and the volume of the other chemical, and you should also look at the equations provided to calculate the mole ratio. Once you've set yourself up for success by writing down everything you know, you go through the 3 steps for getting marks. Calculate moles using N equals C times V. Remember to turn your volume into litres. Then you have to use the mole ratio. You do not get a mark for just writing the ratio, and you do not get a mark for writing a random number and using the ratio on it. It has to be using the ratio on a calculated value. So once you've used the mole ratio, you work out the moles of your second chemical, and you can then get the 3rd mark by calculating the concentration using C equals N divided by V, again making sure that your volume is in litres. Here is an example of how the question would be set out for higher. You'll notice there's way more words than you would have had for National 5. And you'll also notice that it's a lot harder to identify what information goes with what. So the first thing we need to do is look at what chemicals we care about. So we've been told to calculate the concentration of reducing sugars. So reducing sugars is mentioned there. It is your C6H12O6. But read the rest of the question. Reducing sugar is not mentioned anywhere. However, if we read on in where it says calculate the concentration, it says the reducing sugars are present in the diluted sample of soft drink. So where we see soft drink, that is our reducing sugars. And with our soft drink, we have been told that there are 25 centimeters cubed of soft drink. We're wanting to calculate the concentration. This means this is the chemical that we only know the volume for. So we don't know N. That's always needed to be calculated. Volume is 25. We turn it into litres by dividing by 1,000, and we want to know what the concentration is. The other chemical we care about is the other chemical mentioned in the question, failing solution. Failing solution being that copper 2+. So we can see that in the question it tells us the volume is 19.8, and if we look at that first sentence, it tells us that the concentration is 0.025. What I will say is, in questions like this, where 2 bits of information are in the same sentence, you've got to read it carefully, because a lot of people jump to the conclusion that those 2 numbers are for the same chemical. They are not. Read carefully. We've got all the information we have, with the exception of our ratio, which we look at the equation, and it's 1:2. We've written everything we know. Now we can apply the 3 steps, which should be the straightforward part for you. Calculate moles. We can only calculate moles for a failing solution. It's N equals C times V. When we multiply that, we get it as 0.000495, or 4.95 times 10 to the negative 4. If you do not like scientific notation, make sure you set your calculator, and the way your calculator works, to not give you scientific notation. You are allowed to give your answer in scientific notation if you are confident in using it. You don't have to use decimals. Second thing is use the ratio. So we've calculated our failing solution, so the ratio is 1:2, so in this case we're dividing by 2 to get our number of moles of reducing sugar. And then finally, we can calculate concentration. Concentration is N divided by V. We use our calculated number of moles from the mole ratio and our volume in litres from the question to get us our answer. Notice I've not done any rounding until right at the very end. If you round too early, you will lose marks because your numbers are not going to be what we want. Only round at the very end. And if you've got a number that goes on the full way of your calculator, use at least 5 numbers after the decimal place to do all of your follow through. Here's a second question. I want you to pause the video, read through it, and try and fill out the values. I've scored out the number of moles because those are never going to be in the question. So have a go, pause. If you have had a go, hopefully you've identified the numbers, but I'll go through what to do. So with our sodium hypochlorite, so our sodium hypochlorite is what is in our swimming pool. Now, we're not given any information about sodium hypochlorite except that it's in a swimming pool. So our sodium hypochlorite has to be in this first equation. Our sodium hypochlorite is that chemical. It's got sodium, it's got chlorine, and something else to make it hypochlorite. Okay? Then we're told hypochlorite, we then use a standard volume of thiosulfate. So thiosulfate must be the one in our second equation. And it's that chemical. Okay? So our hypochlorite is in our swimming pool water. So our swimming pool water, that is our volume. We want to know the concentration, which means that's all we need to know. Volume is 100, divide by 1000 gets us 0.1. For our thiosulfate, we know that its concentration is there, it's at 0.01. And we were told that the volume of thiosulfate was 12.4. Read that sentence carefully because it mentions both chemicals. Which one is that volume for? 12.4 is for thiosulfate. Now the ratio is difficult in this one because the two chemicals are not in the same equation. What is in both equations, however, is iodine. So if we look, 1 mole of that, of your thiosulfate, produces 1 mole of iodine. And 1 mole of iodine produces 2 moles, sorry, that should have been in blue, 2 moles of, not produces, reacts with 2 moles of thiosulfate. So it's a 1 to 1 to 1 to 2, or luckily, it is just a 1 to 2 ratio. Those were the numbers that you should have taken from the equation. And what you can do then is just go through your 3 steps. So reading the question, take the time. Take about at least 2 minutes to identify what's what and then do your maths, because if you can do the maths, but you've got to set yourself up for success. Calculate moles, N equals C times V, so it is the numbers for thiosulfate. And this time 0.000124 or 1.24 times 10 to the negative 5. The mole ratio is 2 to 1, and again, you've calculated, I'm sorry, I've got this written, this is your NaOCl, and that is your thiosulfate. Not failing solution. The ratio is still 1 to 2, and so you are dividing that by 2. And then finally what you've got is calculate the concentration, and you are taking your calculated number of moles, your 0.00000062, and dividing it by your volume, which is 0.1, to get you that. Notice the numbers for higher are not nice numbers. You're not going to get something that gives you 0.5. You're not going to get something that gives you 100. It's going to have awkward numbers, so like a 0.7, or it might have a few zeros before, like after the decimal place, before you get any real numbers. So just be cautious of that, and always, always, always ask yourself if it makes sense for that concentration. You should never have, concentrations should always be no higher than 2, but they can be a very, 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 very close to 0. So that has been how to do titration calculations in a redox setting. The most important thing is reading the question correctly to get all your information assigned to the correct chemicals. If you don't take the time to do that, you will make mistakes and you will lose 2 marks out of 3, even if you do all the steps correctly.